Okay, these are our types of chemical reactions notes. If I did not give you one of these little foldables, it looks like this, and when you open it up, it has the 5 different types of reactions we're going to discuss. So if you do not have one of those, get one of those from me before we start. All right, so in the last unit, we learned how to write chemical reactions. So in this one, we're going to learn how we can classify those reactions. All right. So we're going to use the analogy of dancing atoms. Okay. So this one is dancing with reactants. When you're thinking about the first 4 types of reactions, I'd like you to think about its similarity to dancing, and I'll show you what I mean. So let's look at the first example. Adam and Barbara are both single. No one's talking about Adam and Barbara being together before they dance. They go to the dance alone. However, they meet at just the perfect time when a song they both adore is playing. They end up holding hands the entire dance. After that fateful meeting, no one ever sees Adam without Barbara. They are forever referred to as Adam and Barbara, aka Adara. Okay, so we're going to represent the drama of Adam and Barbara as a chemical equation. So Adam is going to be A and Barbara is B. So we've got A plus B, and what happens? They make AB. Okay, A plus B, and they make AB. Okay, so if we're looking at our different types of reactions here, what do we see? We see addition or synthesis. I call this a synthesis reaction. You'll sometimes see it called a combination reaction as well. It just depends on your book. Okay, so A plus B produces AB. This is where we have one product. Okay, so we've got 2 elements or 2 compounds producing one product. So you see that A plus B produces AB. Reactant elements combine to make a single compound. All right, and what are they doing? They're combining, they're coming together. Okay, so that's what's happening. Adding, that's where you get these names, addition. So what's happening to them? They're combining to form one compound. All right, let's look at our next type of reaction. All right, the dance continues. Later that same evening, Alex and Brianna, who have been the couple forever, have a heated quarrel and break up. Okay, represent the drama of Alex and Brianna as a chemical reaction. Use A to represent Alex and B to represent Brianna. So here is a different type of reaction. Okay, this is when you have happy couple that breaks up. Okay, and what are they doing? They are breaking up. They are breaking apart. That's what happens. So in a decomposition reaction, this is where we only have one reactant, all right, that breaks up into 2 or more products. Okay, AB breaks apart into A plus B, breaking apart. So it's the opposite of a synthesis reaction where they're combining. These are breaking apart. So these are easy to spot when you're trying to figure out what type of chemical reaction you have. All right, let's look at the next one. The dance continues. Brian and Kaylee are happily dancing when single Adam comes along and starts dancing with Kaylee. Now Brian is alone. What type of reaction is represented below? Okay, single dude, happy couple. And what happens here? The cations switch places. Cation, remember, is your positive ion. What happens? So now we have a new single guy, new happy couple. All right, so what is happening here? We have one element switching places with another element. Okay, so one element switching with another. And just a single element, one. That's why this is called a single replacement. So we're going to illustrate this. We've got A plus B and C, because remember it is single atom and Brian and Kaylee are the couple. And now Brian is alone and Adam and Kaylee are a couple. Okay, so what happened? these two elements switch places on the other side. So again, that's called a single replacement reaction, where one element takes the place of another. All right, let's look at our next example. All right, the dance continues. In their blissful state, Adam and Barbara meet a new couple, Calvin and Daria, and go to the same dance. Adam asked Daria to dance, and Calvin and Barbara decided they will dance together as well. Okay, so here's where you have two happy couples that make two new happy couples. Okay, so what's happening? Once again, our cations or our positive ions are flipping places, right? So looking at that, what happens? Okay, so we've got A and B are a couple, plus C and D. And on the other side, now C and B are the couple, plus A and D. Okay, so who switch places? These two elements switch places, right? So here, what's happening? What type of reaction is this? Well, if we're looking at this, so before there's sort of one element and a compound make a new element and compound. Here, this is where two compounds make two different compounds. All right, this one is called a double replacement. Sometimes you'll see displacement or replacement. The last one we talked about was a single replacement. This is a double replacement. So this is a double replacement. Where we have two happy couples make two new happy couples. Okay, and let's talk about this last one right here. This is the oddball out. This is your combustion reaction. Okay, so a combustion reaction, we're not at the dance anymore. A student decides to light a Bunsen burner. The fuel in this case is propane. So we have some type of fuel in all of these reactions. This reacts with oxygen, which is O2, to produce carbon dioxide and water. All right, these all look the same. Some type of fuel plus oxygen gas, 99% of the time produces CO2 plus water. Okay, fuel plus oxygen produces carbon dioxide plus water. So if we're going along here, a lot of times people will confuse this with a single replacement reaction. But that's not what's happening because they see this single oxygen here. Just remember, you have to have some type of fuel, C to the X, H to the X. Any numbers could fit in here. Plus oxygen, sometimes hydrogen, produces water plus CO2. Okay, if you're not seeing that, it is not combustion. All right, so make sure that you see this. Okay, have to have oxygen gas as a reactant, water as a product. All right, now knowing what we know, based on these, see if you can go through here and pick out what type of reaction. All right, so one of these is going to be decomposition, one is going to be a synthesis, one combustion, one single replacement, one double replacement. So figure out those, that's what goes here. And these are the actual definitions of those. So where do I find those definitions? Well, they are right here in our little cheat sheet. So finish filling those out and let me know if you need help.